Hello, hello. Kate said something interesting. She said, engineers look to the future. I'm an engineer, and I feel like I'm looking at the future right now. This is really exciting to be here today. That's me. That was me when I had a beard. You can go with that. All right, I have control? I have control. So what are we doing today? We're all being engineers today, right? Let's continue being engineers, right? Not just today, not tomorrow, maybe next week, and years and years ahead of us. Like Kate said, my name is Mark. I am what I call myself a master engineer at Broadcom, and I'll get into what I do in a minute. But first, I want to start with a joke. The optimist, the pessimist, and the engineer. An optimist, someone who looks at the future and says, oh, it's bright, someone who's very positive about the future, would look at this glass and say, this glass is half full. A pessimist, someone who's very skeptical, who doesn't really, I don't want to say cranky, but is not very negative about the future, will look at this glass and say, that glass is half empty. An engineer will look at this glass and say, it's actually over-designed. It's twice as big as it needs to be. That joke works half the time. That joke works all the time. Another one, a scientist might look at this and say, it's actually full, completely full. Half of it's water and half of it's air. So was an engineer? Obviously not a comedian. Can anybody tell me what an engineer is? Just yell it out. Yeah, go ahead. Yes, a builder. Any other words that pop into your mind? You're all right. Okay, you're all right. The funny thing is, when I was creating this presentation, I started asking my colleagues, because I couldn't really define it myself. This is kind of weird. Why couldn't I? If a pilot asks another pilot, what do we do? I mean, it's pretty easy. Like, of course, we fly planes. If a chef asks another chef, what's a chef do? They make food. They cook food. But as an engineer, when I asked some of my colleagues, hey, what does an engineer do? There was never really one definition. They came up with a bunch of definitions. Some of them were people who invent things. A lot of the things that you guys were yelling at me. So, like I said, they're all right, but it didn't really. I needed more. I needed better definitions. So, of course, I looked it up, and the best one that I can find of what an engineer is, and I'm going to read this word for word: someone who uses knowledge of science, math, and creativity to design objects, systems, or processes to solve problems. It's my favorite definition of what an engineer is, what an engineer does. Coincidentally, I found this on the Oregon State website, and I say coincidentally because their mascot is the beavers, and you can say that beavers are actually nature's engineers, or like forest ecosystem engineers. So I thought that was a funny coincidence. So there are many different types of engineers, obviously, and you guys have heard a lot of these. Civil engineers deal with building bridges and things. Mechanical engineers build machines. Aerospace, you guys have heard of all of these, like I said. Agriculture engineers, chemical, biomedical, software, right? You guys are doing a lot of software today, writing code, design, code, build, right? There's also a bunch of other different kinds of engineers I see on that wall over there. What's missing here, myself, is my favorite kind of engineering, electrical engineer. That's what I do. And just like all other disciplines, there's many other sub-disciplines. There's different kinds of electrical engineers who deal with power, radio frequency. They deal with signal processing. My favorite in the entire world is semiconductors. That's my specialty. And I will tell you why in a second. But first, I want to tell you, First, I want to tell you about my journey and how I got here, besides just jumping on a plane and flying over here. I started out I was born and raised in Southern California. Hey, and a town called Pacoima, which is right here. It's in the San Fernando Valley. I don't know, you guys have heard of Southern California, obviously, but Disneyland is kind of far away from me. Hollywood's here, but this is pretty much all of LA. I was an average kid who loved to play sports. I loved swimming. I loved riding my skateboard. I grew up in a neighborhood that wasn't, how do I say it? There was lots of gangs, there was lots of drugs, there was lots of trouble. I didn't have a lot of college influences in my life. I didn't have aunts and uncles or even parents who went to college or thought about going to higher levels of education. I didn't know any engineers. But I was always interested in math and science. I leaned on the nerdy side of school, more math and science based studies. I used to bug my parents all the time for a computer. This was many, many years ago when computers were this big, maybe not this big, but they were pretty big, and they cost like $2,000, a large amount of money. And I didn't really know why I wanted a computer. You guys have probably seen these before. They look ancient to us, right? Or to you guys, I'm sure. I just knew I wanted one. Nobody had a computer on our block. But like I said, probably because they were really expensive and I couldn't really tell my parents why or what I would do with it. I just knew I really wanted one. They didn't buy me a computer. And I was really sad, of course. One day I thought they had. They said, oh, Mark, we have a surprise for you. They left and they came back. And I thought, oh, this is it. I'm going to get my computer. But they didn't come home with a computer. They came home with a car. They came home with an $800 car. It was a lot cheaper than a computer. I guess they thought it was more practical. But how much design, coding, and building can you do with this? Not very much. I couldn't even fit a couch in there when I moved. So never got my computer when I was in high school. Like I said, I didn't have a lot of college positive influences until one day in 11th grade biology class, we got a visit from a group of students who had gone to my high school, was from my neighborhood, but they were attending a college called MIT. You guys heard of MIT? I never heard about it before. I never thought, well, what does an engineer do? But here are these 3 people who came in, and they looked like me, and they talked like me, and they came from my neighborhood. And they convinced me that college was a great thing, would be a great experience, and becoming an engineer would be, lots of fun, and you make lots of money, and you get to build things. And that got stuck in my head. And at that point in 11th grade, I said, okay, I want to go to MIT. I want to be an engineer. I studied really, really hard. I tried to get as best grades as I could. I took all the courses that I thought would help me get into MIT. Sadly, just like I didn't get in my computer, I didn't get to MIT. I got into Boston University, which, coincidentally, is as close as MIT as I can get. You see, if this is MIT right here, this is BU, this is Boston University, I got as close as I could to there. It's even closer than Harvard's way over here. Does anybody know what state MIT is in? BU? Massachusetts, right. It's in the name, of course. So, was still, of course, like I said, I sad I didn't get MIT, but I got into BU, which is a great school. I would recommend it for anybody. I studied electrical engineering, and I still rode a skateboard. Rode it through all the town. It was a great place to be until it snowed. It's a really cold place. Snow is not really good for skateboarding, let me tell you. But college was exciting. It was fun. I got to be away from home. I didn't have parents who were telling me when to go to bed. They weren't telling me when to wake up. It was, in that sense, it was kind of cool. But on the other side, I had to wash my own clothes. I had to feed myself. I had to figure out how to get to class and how to get through the snow and how to keep myself warm. So I spent 4 years at BU, like I said, studying electrical engineering. Fell in love with becoming an engineer. I wanted to do this professionally. I wanted to do this for my career. So at that time when I graduated, the best place to go for an engineer was here, Silicon Valley, right? You guys are all surrounded by these many, many great companies, and there's brilliant people, there's brilliant engineers, there's lots of smart people here who are doing amazing things, building amazing, well, I mean, you've seen it all downstairs with the computers. You've seen it with just in the way that we travel now and medical fields. There's so much going on, and this circle probably should be bigger, right? So we have lots of tech companies also in San Francisco. So I was happy to be back. I've worked in many different cities you probably recognize here, and like I said, many brilliant engineers. And something happened during that time that I wanted that computer when I was really young, before college, and after when I became a professional, was that computers were no longer this big. They started to shrink, and they started to shrink really fast, and they started to become a little cheaper. I almost fell off right there. That's why there's tape. That would have not been funny for me. So I was saying, so the computer that I finally was able to buy fit in my hand, it fit in our pockets. The amazing thing that happened was because of all these brilliant engineers in Silicon Valley and other tech cities around the world, they were able to take that big old computer that costs a lot of money and make a definitely more powerful machine that fits in all of our pockets. Oh, sorry. So I was up here for 13 years helping with the innovation of microprocessors and semiconductors and helping with the progression of building all these wonderful machines that we now love and adore and can't live without. Now I work at a company called Broadcom, and we are based out of Irvine in Orange County, and I am an integrated circuit design engineer. And like I said, we work on semiconductors, and semiconductors are everywhere. Life would be very different if semiconductors did not exist in our lives. You see all these products here, but this is just a small sample of where you can find semiconductors. At Broadcom, we work on communications chips, and I'm really proud to say that some of the chips that I've worked on are chips, and I'll show you what a chip is in a second, but some of the products that I've worked on are in your phones, they're in tablets, they're in those big stations, those big fake-looking trees that are cell phone towers. They're in these big clouds that do all of our storage. Semiconductors are everywhere, and the ones that I'm part of a team that helps produce crosses, it says 99.98. I don't know if that number is exactly right, but lots and lots of the traffic that even with the phones that we're using today go through a Broadcom chip. And I'm very proud to be part of a company that does that. So what do I do on a daily basis? Well, as an engineer, I work on computers. We use computer automated to design, and some of the stuff that I learned in high school and in college, stuff that you're going to see in the near future, hopefully. But I use geometry, algebra, calculus, physics, chemistry, statistics, programming, design, coding, and building, of course. All of these things that I learned in high school and in college and just playing with electronics are things that I use today that, on a daily basis. So let me go back for a second. No, I don't want to go back for a second. So what would life be without semiconductors? Well, there's a tape drive that's downstairs, and if we didn't have semiconductors, I think this is from this is probably the 60s, we'd have to store all of our pictures on big old drives like this. And I don't know how big that is. That probably can only fit one picture that you take. After the advent of semiconductors, of course, we can put thousands and thousands of pictures on these flash drives, right? Life without semiconductors. When I was in school, we used chalkboards and we used projectors. Do you guys use projectors? These projectors nowadays? Yeah. Maybe some of these whiteboards. Life without semiconductors. Does anybody know what this is? Telegraph. This was an early texting machine. But now, of course, funny thing, I was looking for somebody just texting, and they were all kind of boring. I found a story that some areas of the world are now designating sidewalks as a texting zones or cell phone use zones or no cell phone use zones, so people don't bump into each other. I thought that was kind of funny. So life without semiconductors, we wouldn't have texting. You wouldn't be able to text your friends. All these anagrams, OMGs and stuff. 3D printer, this is kind of a joke. But I mean, these didn't exist at all. I couldn't find anything really. I mean, of course, we still play with Play-Doh, but life without semiconductors, this would be our drones. Look at that. Really ancient, really ancient cameras on pigeons. That's not a very fun drone, right? This is what we have because of semiconductors. Before I go a little bit further, I'm going to talk about just technology for a second. I don't want to try to overwhelm you guys, of course, but if we can think about, oh, that didn't work very well. So if you can think about for a second, does anybody know what a microprocessor is, a CPU? Right? If you were using those Raspberry Pis today, you saw those little black boxes right in the middle. That's the brains of any computer. That's where it does all the computations. Just like your brain. Right? Your brain has millions and millions of cells in your brain that tell you when you're hungry, that tell you to how to tie your shoe, they tell you, your brain talks to your body, right? We use semiconductor technology to build microprocessors to kind of do the same thing, except, of course, on a computer, right? We tell the computer that the phone's ringing. We tell the computer that, we use the processors in computers on your phone to say, I'm playing a video. We use it to say that you're texting. So we take billions and billions and billions of transistors, and we put them on a silicon wafer, and we program it, right? The programs that you're writing today talks to hardware. The software that you're writing, those programs that are the GUIs that you're clicking on and you're saying play 60 or play 30, and you're making it do many different sounds, talks to that CPU, and then that CPU sends messages to either the speaker or the graphics area. So I guess the point of this is I wanted to say that transistors are the basis of all of this stuff when we talk about silicon. This battery's dying. I don't know. Okay, here we go. So here's the Raspberry Pi. Okay, so right here, you've all seen this. These little packages there's billions and billions and billions of transistors on this particular, we call it a package, but we can call it a chip. It's a microprocessor. It talks to the rest of your Raspberry Pi, like I said, and sends out all these instructions. How are we able to fit billions and billions of transistors on one chip, one microprocessor? Well, like I said before, that big machine that I wanted 20-something years ago, we were able to shrink that with brilliant engineers have been come up with different ways of just constantly shrinking and shrinking those transistors so that we can fit billions and billions on one chip instead of a couple 100,000. Now, how small are these transistors? This is kind of a representation of that, and it's kind of hard to really see how small one transistor is. But if you can think of this as your hair, this is a human hair, this big circle right here, if you were to pull it off and kind of try to look at it as if it were like a straw or a tube, the diameter of that is 50 microns. One single transistor is 2,500 times smaller, right there. That's how small these transistors are, right? Looking at it the other way, if we have a basketball, it's 38 million times larger than a single transistor. Of course, it's properly inflated. Tom Brady didn't have anything to do with this basketball, of course. So I talked a little bit about progression and going from this big to this little, and how now that phone is more powerful than that computer that I ever wanted. The stuff that you kids get to play with is so small, but it's so fast, and it's so much more powerful. I'm actually kind of jealous. That would have been perfect for me when I was a kid. But microprocessors in phones today run, we call it gigahertz speed. Before, it was in the megahertz speed. It was really, I mean, ask some of your chaperones and some of your teachers. I'm sure they remember the days of where you had to load an image, and it would take a minute just to see a picture because it would slowly load. But like I said, we've hit billions of transistors. Before, 250,000. And we run at extremely low power. You don't have to keep this plugged in at all times. Of course, this computer always had to be plugged in. Graphics were not as good, of course, and there's so many more apps here that you'd have to load different things on here. It was not as fun. Trying to compare that to any other industry in the world, let's talk about cars. If the car industry were to progress as fast as the semiconductor industry had, then my car here should now be going 3,900 miles per hour. I'd be able to get to New York on 1 tank of gas. So it's been an amazing last 20 years or so because just the progression has been outstanding. It's been amazing. I mean, lives have been changed for the better, I think, because of semiconductors being in everything that we use every day. Medical, transportation, entertainment, you name it. Speaking a little bit more on engineering progression, it's not just related, of course, to electronics and semiconductors. Something as simple as this old skateboard here. There's a piece of wood with some wheels. I mean, this doesn't look like you can do any tricks on that. It would be really hard to ollie or do anything on that, right? So even in other industries, and everything we use, work with, or wear is engineered. This is a much better skateboard, right? The wheels are of higher quality, the trucks, even the gear. This is my daughter. This is Nora. She's 4 years old. She's learning still. But even the gear that we wear has been engineered. I mean, these knee pads and wrist guards, 20 years ago when I was riding a skateboard, they weren't as high-tech as they are now. And of course, much safer, even the helmets. So everything we use, work with, or wear has been engineered. But it's not just about inventing new things. It's about taking technology and building upon that and progressing and making things much better. This is an old phone here. And anybody know what this is? Camera, right? Of course, now we don't, as far as improving technology, now we have a camera phone. This is a joke. This is a joke, yes. That reminds me, I want to take a picture. But like I said, now this powerful little machine here, you know what? Can I get in it? Let's say, can everybody smile? I'll see how that came out. So yeah, it's about improving on technologies, improving things that we use every day, putting them together. Sometimes we fail. Sometimes we fail at putting things together, but we learn from those. Does anybody know what this game is? It's a football game, but it's called Tecmo Bowl. So, I mean, even entertainment industry, the progression, of course, this looks horrible, right? But this used to be, you have a hat, a Nintendo hat. That's cool. I like that. So we used to use that controller to play this game. But now, of course, I mean, you can't go from, progression is an amazing thing. And these are all things that engineers have fun and work on. So I have a redefinition. What is an engineer? Someone who uses knowledge to solve problems. It's actually pretty simple, pretty easy. You guys are all solving problems every day. It's in your lives. It's all around us. If you took a shower this morning, hopefully you did, or a bath, you're performing acts of engineering all the time. You got in, maybe it was too hot. Your body told yourself, you should turn it down. It's too cold. So your brain was telling your body, it was acting as a control system. Was giving your body, your body was giving your brain feedback to turn it up or turn it down. That's an act of engineering. So simple as that. Yeah, this is a guy. He's trying to get over. He's trying to get to the other side. I don't know why he just doesn't walk around. Maybe it wasn't a good. But there's always more than one way to get to a solution. There's always more than one technology to get to what you want to get to. Okay? Let's play a little bit of a game. So I mentioned earlier, I was talking about pilots talking to pilots, and sometimes I like to give like engineering names. So if I can call a pilot a flight engineer, right? What would you say a food engineer could be? Chef. What would you say a lawn engineer would be? Lawnmower. A gardener? A gardener would be a lawn could be a lawn engineer. What about a health engineer? A doctor? Educational engineer? Teacher. How about 3-point knockdown? Man, you're fast. If you could think of any more cool thing, I like to play this game all the time where I can try to make it sound like, try to put engineer on the end and try to get you guys to. If you could think any more later, please come and tell me. So yeah, if there's a problem, solution. We're all engineers, guys. We do these things every day. Other acts of engineering that I just looked up and found a bunch of memes, right? This is an act of engineering. Somebody maybe they lose their keys all the time and maybe they're tired of the cables being on the floor. That's an act of engineering. If you can't see, those are Legos. Here's another act of engineering. I don't know, maybe the cord wasn't long enough and they had an extra shoe laying around. I don't know. Act of engineering. They're getting their phone charged. This guy, this is an act of engineering. Why? Maybe here's the thought process. Maybe he came out with a hat and he learned that maybe it wasn't big enough to cover his shoulders, right? So he had a problem. His shoulders were going to get a sunburn, right? So he came up with a way to cover his whole body and still have his hands free. That's an act of engineering. Other acts of engineering? Have you guys done this trick? Yeah? You want to make your speakers louder? You want to make your phone louder? It's a good way to do it. That's an act of engineering. This kid, I don't know if he's lazy or a genius or both, but he wanted his hands free and he was a little cold maybe, so he puts his phone right here up on. It's an act of engineering, guys. We're all engineers. We do this all the time. This kid, I should have brought a dustpan. This kid figured out how to take a selfie with a dustpan. It's an act of engineering. Now he looks like the coolest kid on the block. All right? We're all engineers, guys. Now, being here and doing design code build, hopefully will also turn you on to software engineering, and hopefully you'll be able to pursue careers in engineers. I have a list of things that I like to say, and I used to call this you may be an engineer if, but I think the title should be, as I wrote it here, I just fixed this last night, you're well on your way to becoming an engineer if you like to solve problems. If you could take information and use logic to address issues and problems, that guy who needed, the umbrella, he was able to take that information, use logic, sort of, and solve that issue. Teamwork is very important. All of these devices and everything that we're doing, and you're learning today that working in teams will help you progress, and it's very important to learn how to work in teams, even when you get into higher levels of education and professional life. Can you troubleshoot and learn from your mistakes and failures? Of course you can. You guys are rock stars at falling down and always just getting back up. Even today, you're probably writing code or doing things differently because of something that you learned that didn't work before. Do you have the ability to look for alternative solutions? I mean, like I showed before in that picture, there's more than one way to get over that wall, right? Alternative solutions. Do you love to tinker? Are you interested in how stuff works? Now, I wasn't a big fan of Disney before, but my 4-year-old Nora, she loves Tinkerbell, and she always makes me watch it. But one thing I just figured out is Tinkerbell's an engineer. She tinkers. That's in her name. You guys are writing code today? Design code build? The word hacker intrigues you? Yes, yes, yes. Are you interested in nerdy stuff? Yes? Yeah, it took me a while. It took me a long time to figure out that I was and admit it. But the sooner you do, and the sooner you embrace it, you will go far, trust me. I have guidance for students here. But the one thing I want to just focus on is right here. I truly believe as an engineer, if you guys truly go into higher levels of education, you get your bachelor's degree, your master's degree, your PhD in engineering, I think you can do anything. You'll be able to go into anything in life. I have friends in college who were engineers, went to law school, they went to medical school. It's just about learning how to solve problems. That's it. Going to engineering school gave me all the tools that I needed to figure out how to attack and solve problems in a particular way. By the way, one of those guys who came to visit me, who convinced me to go to college and wanted me, one of the kids who was going to MIT, like I said, in high school, who came to visit us, he's now the Secretary of State of California. He's an engineer. We've even had a president or two, maybe, of the United States as an engineer. Herbert Hoover was a civil engineer. So engineering will take you far, kids. Thank you.
All right, so we have some questions. I know everyone's been really excited. Thank you so much. So we're going to alternate sides of the room. Let's get started here.
So for like microchips, and like Broadcom makes microchips, right? So,
yes.
I just have a question. So for microchips, you need photoresist, the template, and the silicon quartz, the carbon, how to do it, and then heat it with 3,000 degrees. So do you provide all of that, or?
Okay, so that's a great question. What he's asking about is the actual process that we use to fabricate the chips. Is that right? So no. So we at Broadcom, we design them. We do it on a computer. We use CAD. We use software to do it. All those tiny transistors. I showed you the picture of the kind of like that green blob. That was a chip. You saw that, right? So we then send that out to a manufacturer, and they build it for us. Yeah.
Have you ever like helped any like other countries like Malawi or like any because I at my school like we're doing a project and it inspired by William Kamkwamba. Like, have you ever worked with someone from there, like around like a place where they couldn't really access those materials?
I see. So you're asking if in other countries that don't have modern technologies, that if we've ever worked with them. I think there are lots of programs. I haven't worked directly, of course, but there are lots of programs to introduce technology into areas where they don't have access to like the internet and things like that. So the answer, I guess, no, not directly, but I've heard of many, many programs that engineers do go into areas like that and help.
Great. I've got another question over here.
What type of topics do you have to major in college to do engineering in general?
So the question was, what kind of topics do you mean? Do you mean classes? What kind of classes do you have to take? So the question was, what kind of classes do you have to take to major in engineering? So most of it is math and science based, and I showed a little bit up there. It was calculus and physics. It was very heavily on the math and sciences, of course. But I would recommend to also take some arts, and I think it's been a while since I've been in college, but I think you are allowed to take a few other different kinds of classes. It's very, very beneficial to you if you're well-rounded, if you know a lot about everything, essentially. So as long as you have an open mind and time to take more classes, I would definitely say you should.
Have you ever worked with any major Have you ever worked with any major companies like Apple or Microsoft, like you personally or just your company?
Yes. So she asked, you guys all hear that? Yeah. Okay. I guess I don't need to repeat it. We supply, so Broadcom supplies chips to companies like Apple, companies like Google and Facebook, and all these companies that you know. You can't really actually go buy our chips at a store. I mean, they'll sell Broadcom chips at Fry's. We sell all of our chips to companies that you're very familiar with. Like I said, Apple, Samsung, you name it. Anybody who does products that have to use internet communications will probably use a Broadcom chip.
Great question here.
What is your favorite part of being an engineer?
What is my favorite part of being an engineer? Coming to things like this, being a part of a team that helps push technology. And when I say push technology, what I mean is we go from that big computer and trying to figure out the problem of making it as small as possible. Trying to figure out the next processor that I'm working on should last 2 days without having to plug it in, or it should be twice as fast. So constantly pushing and pushing the technology and trying to make products better for everybody, trying to make it a better world.
How many microchips have you done?
Where are you?
Here.
How many microchips have I done?
Yeah.
Ooh. Probably in the range of 50. I've been on teams that we've manufactured, designed 50 microchips in the span of 15-year career, 18-year career. It takes a long time. I will say this. It takes about a year and a half from start to finish.
Great question here at the back.
How much money did you make being an engineer?
How much money do I make? I make a lot of money, guys. A lot. No, it is a personal question, but it's a lot. It's hard to quantify what a lot is to you, but I will say that I don't have any complaints. I see hands.
Yeah. So, based on the style of modern or old products, is there an old version of something that you like more than the modern?
Say that again, I'm sorry.
So based on the style of modern or old products, is there an old version of something that you like more than the modern?
Yeah, there's a lot of versions of old stuff that I like, but it's only because, I showed you that video game, and it's hard to, like I said, it's hard to play that video game after playing a game like Madden or FIFA or something like that, because the graphics are so good and it's so realistic. But there's a part of me that kind of takes me back to being a kid and remembering, those wonder years that I say that. So yeah, there's a lot of products, old things that I enjoy, but only because they remind me of certain times in my life that I enjoyed.
All right, we've got a question back here.
Does your company have any competition with Xilinx?
No, I don't think so. Do you know somebody who works for Xilinx? Are they engineers?
Yeah.
Yeah.
They design computer chips as well.
There's tons. We're in Silicon Valley, right? You can throw a rock and probably hit an engineer.
Except don't do that.
Don't throw rocks at engineers.
We have a question over here.
Question.
What do you think that is the next big thing engineers will focus on improving?
Next big thing. Oh, I wish I knew. What I would want, probably this holograms. I mean, I would love to watch like a football game, but holographically. You know, that's something that interests me. I don't know if we're there technology-wise. Space travel is another big one that hopefully will be. I mean, we're progressing so quickly. It's hard to. There's so much that I would love to see progress.
All right, we've got another question back here.
What do you do in your job specifically? Like, what part of the chip do you work on?
Yeah. So when we do the processors, my main focus is making sure that every single one of those tiny little wires and every single one of those transistors is going to be manufacturable. Meaning when we send it to get fabricated, when we send it to actually get built, that it doesn't fall apart, that we don't have any shorts. So my main focus is to make sure the chip is going to work after it's built.
We have a question over here.
What are your work hours like? Like, when do you get there and when you leave? Like,
Yeah.
basically, what's your day like?
Yeah. I drop my son off at school. It's not really, it varies. Let me say that. So it depends on the schedule. It depends on where we are in the process of the actual chip design. So it can go, it can be as many as, I don't know, 60 hours a week. I mean, that might be lowballing it, but there's different times where it's not 9 to 5. But I work from home sometimes too, so it's hard to judge how many actual hours that I am working. But I will say, if I don't really count because I really love what I do. So if you love what you do, it's not that it makes it easier, but you forget that you're actually working.
Great, thank you. Another question here.
So of course, in every career, there are some things that you don't like. So what are the setbacks and cons of of engineering?
I like that question. It's not all fun and games being an engineer. I sit a lot. I sit in a computer a lot, and that part I don't like. The offices that we work in are kind of more not cubicle, but they're office cubicle based. So sometimes if you want to be social, you kind of have to get up and go look for people. It's always good to get up and stretch the legs a little bit. So a con I would say is I sit more than I should. But I am looking into getting one of those desks where you stand. I don't know if you've seen those. It's also more healthy for your body. And again, another con would be I'm in a cube a lot more than probably I want to be. It's all about balance, guys. I mean, it doesn't always have to be sitting at a desk working on technology. I mean, I like to mix things up in my life that keeps me happy. An equal balance of, it could be anything, taking a hike. I still ride my skateboard, of course, with my daughter and my son. Having hobbies that are kind of outside. So it's all about a life balance. And you guys will get to that when you get older.
Cool, we have a question over here.
Are engineers entrepreneurs and vice versa?
Yes, definitely. Are engineers entrepreneurs and are entrepreneurs engineers? Short answer, absolutely yes. Some of our greatest CEOs were engineers, right? Some entrepreneurs who are starting their own business are engineers. I have friends who've started their own business, maybe not even related to the engineering field, the technical field, but they're engineers. And I would also say entrepreneurs who don't have engineering degrees, I would also say they perform acts of engineering. There's tons of problems to solve. So yes.
Great, we've got another question at the back here.
What smartphone do you use?
What?
What smartphone do you use?
What smartphone do I use? I have a Moto X. I have a really cheap smartphone, is what I'll say.
I like
Not because I don't make a lot of money, guys. Yes.
What is the what is one of the most important achievements that have been made from when you were a kid till now? Like, what do you think?
Oh, that would take me a long time to think about, because there have been so many advances in the last 30 years that, I have no idea. I mean, I do contend that semiconductors, actually, I will say that it's been the advancement of semiconductors and the way that we've been able to use that technology to get everything that everything that's electronically around us, like I mentioned in that picture before.
All right, I'm at the back here. We've just got time for a couple more questions. So here's another one for you.
What happens if the system crashes?
What happens if what system crashes? Any system?
Yeah.
I don't know. I'm not a software person. You got me on that one.
We have a question over
It's not my fault. Blame the software.
If you weren't an engineer, what other career would you pursue?
Oh, I would love to have been a professional basketball player. I'm not a skateboarder. You know what I do a lot? Videos, movies. I like to be creative in that way. So maybe a career in that. Public speaking. Like this? Comedian? Not comedian. No, that's too hard. It's hard making you kids laugh.
All right, here's another question.
Besides silicon, how many other semiconductors are there?
Oh man, you're putting me on the spot. Chemistry question. 5? I'm trying to see the periodic table in my head. There's only a few. There's only a few elements that can be used that we call semiconductors. Silicon, germanium, I think there's like 2 or 3 more.
Is work stressful?
Is work stressful? Sometimes. Sometimes it is. Sometimes it's hard. But like I said, when you see the products that you build and how it's enhanced people's lives, it makes you want to push. It makes you want to work harder. It makes you want to go farther than you have before. So yeah, sometimes it is stressful. But rewarding.
What do you plan to do in the future?
No, that's not a funny question. What do I plan to do in the future? Man, you got me on the spot. Like in the near future, well, I have 3 kids, so I plan to hopefully convince them or help them become fully functioning adults. Do you mean career-wise? If you mean career-wise, I don't know. I have a few things in mind, but I don't want to talk about those right now. Yes?
Did you meet a guy named Arvind at Broadcom?
Do I know a guy named?
Arvind?
Arvind, yes, I do. What's Arvind's last name?
Agrawal?
No, I don't.
Dang it.
Sorry.
Here we go.
Did you take a lot of APs and honors classes in high school?
Yes, I did. So she asked if I take a lot of AP courses and honors courses. Yeah, I did. And it was difficult, but it was, again, worth it. It was absolutely needed to get into to college for sure. Which courses? All of them. History, calculus, chemistry, as many as I could. Yeah.
Did sports ever influence your engineering career?
Sports influencing my engineering career. I do play basketball at work sometimes during lunch. I think it helps me be healthy. But as far as helping me with designing chips, probably not.
Over here, another question.
Have any of your microchips actually backfired?
Ooh, so has any of our chips failed? Yeah, chips fail all the time, and there's many different reasons.
What happened?
So some will burn up, some will get too hot. Whether maybe your phone might die earlier than you have to. There's defects, of course. Things happen all throughout the design process that can fail. So yeah.
I was wondering if your company has ever suffered from a hostile takeover, or your company has done a hostile takeover.
Our company, so the company that I work for is 10,000 people. 10,000 people, it's a lot of people. And it just didn't happen, over a few years or so. But the company Broadcom is actually a combination of many different companies. Some were merged, some were acquired. I don't know if you'd call them hostile takeovers, but yeah, there's been acquisitions of other companies, purchases of other companies. So yeah, I mean, to build a company this large, you kind of have to buy other companies.
All right, we just have time for a couple more questions, so I've got one here.
What's the coolest thing you've done at work?
The coolest thing I've done at work? Well, like I said, I like to talk a lot about that progression and seeing that, the chips that we made 5 years ago are obsolete. I mean, they're not used anymore. So the stuff that we're working on now and the fact that we're able to get smaller chips and faster chips and use less power is something that I'm very proud of.
All right, I've got one more question over here, and then here we go.
Did you apply to a local college?
Did I apply to local college? No, I don't think I did. So when I was thinking about college, I wanted to get away, as far away as possible. And I couldn't get any further than Massachusetts, or else I'd end up like in the water somewhere. So yes, I did apply to as many colleges as I could, as far away as I could. I don't know, I was feeling adventurous that day. Somebody asked why. Are we done? Oh.
So you said that the chips take about 1.5 years from inception to production.
Yes.
But you also said that chips go obsolete within 5 years. So
depending on the application, but yeah.
Okay, so after that 1.5 years from inception to production, how long until that is actually being used in a product?
Yeah. Again, it depends on the application. So cell phones have a quick turnaround, right? People are always looking at the specs. You're like, how fast is this going to run? How much power is it going to use? How much memory can I hold? But if you're talking about like those big base stations or cloud services, those chips last longer. So they don't go as obsolete as the ones that are in your phone. So again, it depends on the application. But yeah, cell phones will go obsolete. Cell phone chips will go obsolete faster than the other kinds of applications.
Great. So I just have one last question, and you've answered a lot of great questions, and you guys have asked a lot of amazing questions. So if you have one piece of advice that you would give to middle school students today as they go forward and all the amazing things they're doing, what would be your advice to these students and others today?
Keep having fun. Find things you really love to do and play with, and keep your minds open to new things and new ideas. This is great. I mean, the fact that you're here tells me that you are open to new ideas and you want to learn new things. But keep it fun. I mean, you're only a kid once, Kate.
Absolutely true. All right. Thank you so much. You've done an amazing job. Big round of applause for our incredible rock star. All right. Let's hear it for Mark.